If these Next.js components look normal to you, and this server action looks just like all of your other server actions, you need to watch this video because there's a massive design problem with all three of these files that I showed you. Welcome back to Web Dev Simplified. My name is Kyle and my job is to simplify the web for you so you can start building your dream project sooner. And in this video, I'm going to be talking about the data access layer. And I'm not just going to give you a basic overview like many other YouTube videos do. I'm going to really dive into why it's important, what it is, and how you can get the most out of it. Because I feel like most other videos talking about this really miss some of the most important parts. So to really get an understanding of what code we have, why it's bad, we first need to understand what our application does. We essentially have three main pages we're worried about. We have a Your To-Dos page right here. We have an admin page that allows you to view all the to-dos for every single user. And then also we have a login page. So if we try to, for example, access the admin page when we are not an admin user, if I click on this, we're going to get redirected back to this homepage. Or if I'm not even logged in at all, for example, I have a null user here, you can see I get redirected back to the login page. So I have admin checks set up as well as the ability to check to see if a user is logged in or logged out. Currently, I'm just faking what the current user is by hard coding their ID, but that works good enough for this particular application. So let's go back to our /todos page to understand what the problem in our application is. Now, technically everything works, but we have issues with how we're accessing our data in a way that is not really optimal, especially when you start to scale your application to be larger and larger. And that's because, as you can see here, anytime that I'm trying to access my data, I'm doing it directly inside of whatever that component is that's accessing that information. So for example, on my to-dos page, if I want to access the to-dos, I'm first checking to make sure I have a user, I'm redirecting the user if they're not logged in, for example, and then I'm finally going ahead and getting the to-dos by directly accessing my database and then rendering out the content related to those to-dos. It's the same thing on my admin page, but I have extra steps because not only do I need to make sure there's a user, I also need to make sure that they're an admin user so they can access this information. Then I'm getting all my to-do related information and finally rendering that out to the screen. All the rendering code is fine, that doesn't really matter. It's mostly how we get our data. Finally, in our actions, we're doing the exact same thing. I'm getting all my data from the client, and then I'm going ahead, I'm making sure I have a user, redirecting if I don't, directly accessing my data, and directly doing all my revalidation in case I'm doing certain types of caching. In our particular example, since we're directly accessing the data in our components, we don't really have a good caching system set up, and I'm not even doing any caching, so that's already red flag number one if you want to cache your information. This way of doing your data access makes that incredibly difficult. And the second red flag is that now if I need to get to-dos on another page, I have to repeat this entire code. I have all this boilerplate code for accessing the user, making sure they're okay. And the big problem is what happens if someone just forgets to put this check in right here? Now all of a sudden anyone can access this admin to-dos page, even if they're not an admin. So it's really easy to accidentally mess up when you're writing your code, especially if you're doing a lot of different queries across your entire application. This is why generally it's recommended when you're trying to either access data or modify data inside your database that you go through something called a data access layer, which is essentially a separate layer that's all about just getting data or modifying data inside your database. To show you what I'm talking about, let me modify this code so that we have a data access layer. Now I just went through and updated all of the code, and you'll notice immediately when I'm on this to-dos page here, the original approach, I first got my user, did my redirect, and then directly queried my database and just got back all the information. But in this new approach, I don't access the user information or anything like that. Instead, I'm just calling a simple function, get current user to-dos. Very self-explanatory, the name tells me exactly what it does. And most importantly, I'm also selecting only the columns of data that I really need inside my application. Now you could do this column selection inside the data access layer or outside, it's entirely up to you, but that's already one massive improvement is we're only selecting the columns we need, limiting the amount of data we're getting from our database and hopefully speeding things up. Also, I don't have to worry about all my user checks or anything like that because it's all handled inside this get current user to-dos function, which we'll look at in a little bit when we look at the actual data access layer itself. It's the exact same situation with my admin page. You can see here, I just have one single function called get all to-dos that gives me all my information, and that function takes care of all the columns and everything else for me. And if we look at our original approach for this function, you can see it's much more complicated. Get the user, redirect the user, check if they're an admin, access the database. All of that complicated code is essentially wrapped up inside of one function that handles everything for me. I did the exact same thing with our actions as well. You can see here we just have an insert to do function and an update to do function that do all that information for you. Unlike in our naive approach that we originally had where we were accessing our database and getting all of our user information, you can see this very complicated function with all these different things going on inside of it has now been changed to just one single line, which makes it much easier to use throughout my application, especially if I need to call update to do somewhere else. I can just use this one function instead of copying over all the code. Now, the way that this entire system works is entirely based on a data access layer, which I just have inside of a file here. So inside the to-dos, generally when I write my applications, I like to put them inside feature folders. So I have this to-dos features folder, and you can see I have this data access layer, often abbreviated DAL, and I have the basic version of it because we're going to go over a much more advanced version at the end of this video. But you can see inside of here, I have two files, queries and mutations. And that's because most of the time in your application, you have just certain things that give you data, those are queries, and you have certain things that modify data. And I like to keep those separate because the mutations are usually very simple. It's just like delete, create, update. There's really only a couple of those. While the queries could be much more complicated because you can obviously query your to-do data in many different places in many different forms. So I like to break those out into different files. So let's take a look at what those actual files look like real quick. You can see we have those two functions, get current user to-dos and get all to-dos. And for the most part, all I did was I took that naive code and I kind of moved it directly inside of here. So you can see all the code for accessing my user and redirecting if they're not currently logged in is all handled inside of here. And then I'm directly accessing my database and I'm specifically passing along the columns that I need. Here in this particular example, I'm taking those columns in as an argument that just has a really long TypeScript type to make sure everything's hooked up properly. While in the get all to-dos version, I'm just hard coding the columns that are being returned. This approach of hard coding the columns or passing them in is entirely up to whichever way that you want to go based on your application, but I find pretty much any system you're going to want to select just the columns of data you need instead of selecting all of the data, because again, it'll just be slightly more performant and not pass around as much data. But otherwise, you can see the code for these is pretty much the same. Do your user checks and then access your database information. Now, the nice thing is since these are individual functions, I can easily throw caches on these. For example, if I want different cache tags I could throw on there, if you're using that caching system inside of next.js, you can do whatever caching you want because now you have access to these functions directly. And the really great thing is if, for example, I wanted to access the current user's to-dos for some type of dashboard page, well, I could go to that dashboard page and I could just call this function real simply and pass in, whatever columns I need to get to be able to render out that information. And now I can get that. All my user checks and everything are handled for me. I just need to call this one single function. The mutations are pretty much exactly the same. You can see what I've done inside of here. All my different user checks, access the database to do the mutation, and since I can handle my caching, I can do all my revalidation in here automatically. So all the user checks and caching information is all handled in this function. And same thing down here with update to do. I get all my user information, I do my update, I do my revalidating of my cache. And in this particular example, if, for example, the user is not having access to that to do, it's just going to return an error that says you do not have permission to update this to do. And to kind of show you what that looks like in the application, if we go to the admin page, I have access to this to-do down here because I am an admin. But if I go up here and I try to select one of these, it'll just give me a warning that says you do not have permission to update this to-do. Essentially, it returns to me whatever is in this error section right here. And again, that's happening because I'm trying to update the completion status of a to-do that I don't have access to because I'm not that current user, which is what this equality check and all this other stuff down here is doing. The overall logic of how that's working is not super important, but we've kind of shown that you can have different error states inside your code. Now, this may look like a great step, and oftentimes when I watch videos on data access layers, this is where they stop. But there's actually quite a few problems with this approach that are not immediately apparent when you first start using it. The biggest one is that you have some hard-coded stuff inside of here. For example, if my user does not exist, I'm always redirecting them to the login page. That's fine if you're inside your application and navigating through it normally, but what happens if I now want to implement an API for my application that has an update to do and an insert to do function that's going to happen? Well, I create my API route and I want to use my data access layer. I mean, that's the whole reason I created it. But when I call insert to do in my API, it's going to redirect this API to the login page, which is not at all what you want. If you try to access an API and you're not authenticated, you should probably throw some type of error or let the user know, hey, you're not authenticated, do whatever it is you need to do. So the way you use your application may be different if it's an API, if it's an actual route you're rendering, or maybe I just want to show the user a button that says log in instead of a to-do list. It'll just replace that with a button, but still render the page for them. So there's many different ways I may want to handle these types of errors, whether it's redirecting the user, showing them a button, throwing them an error, whatever it is. And this is very much hard-coded. I can only do one particular thing, and that's what all my different implementations are going to handle. Instead, I essentially want to create a system that has all this data access logic put inside of its own file and its own functions, but I want to be able to do different things with the information returned, whether it's a success or an error, and I want to know what different types of errors I get from that type of information. Now, there's a ton of different ways to do that, but I want to show you one particular example of doing that, which is a very advanced way of accessing a data access layer. Now, I just swapped over all of the code to a more advanced data access layer, and the easiest way for me to explain the big difference between this and the basic version is actually moving into a TypeScript specific file that has the types for this particular system. And this system actually, instead of returning just a result, is actually going to return to you either a result or an error, very similar to how like XOD validation would work. And that is all based on this DAL return, or DAL, or data access layer return. It has a generic type, which is whatever your data is. Is it a to-do list? Is it, the admin to-do list with some extra information? Whatever it is, it doesn't matter. And then finally, it has some type of error. And as you can see here, if the success is true, it returns the data. If the success is false, it returns to me an error. And I have in this particular application 4 different types of errors. You could add or remove all the errors you want, but I have a no user error for a user that's not logged in, no access for a user that's trying to access something they can't, for example, a user trying to do admin things when they're not an admin. I have a drizzle error, for example, when your drizzle query fails for a drizzle specific reason, and then just an unknown error for handling any other type of error that could possibly come up. And if we take a look at how our code is actually used, it's very similar between the basic and advanced way. This just gives you much more flexibility. For example, if we look at the old way of doing things, you can see what I'm doing is I'm calling get current user to-dos from that data access layer and passing it in the columns I want. In this new way, I'm calling get current user to-dos, passing it in all the columns I want. The only big difference is I'm wrapping it inside of a helper function called DAL verify success. All that's doing is it's taking that data access layer object I'm getting returned, which I know is either a success or a failure, and it's essentially forcing the successful state. And if there's an error, it does different things, which I have default behaviors set up for. If we take a look at that function, which is verify success, it essentially goes through 3 different steps, which is the boilerplate default behavior I want for most of my application, but I can then overwrite this if I want. The first one is I redirect the user if there is some type of login error. So if I go to this DAO login redirect, all it's doing is checking, okay, if it's successful, don't do anything. And if the error is specifically that the user is not logged in, then redirect them to the login page. So all this is doing is either redirecting them to the login page or it's just returning the data as is. Same thing here in the unauthorized state. If they're not currently authorized, it's going to redirect them to the home page or whatever path I pass in, or it'll just return the data as is if it's successful. Finally, this last one, DAO throw error, all it does is if there's an error inside my application, it'll just throw that error. And this is mostly to handle any of those like unknown errors or drizzle-based errors that I don't really have a handle for. It'll just throw those as if anything was happening as before. That's how my old system was working, so I just implemented that with this throw error. And all this verify success does is it essentially checks, is the user logged in? If they're not, redirect them. Is the user authenticated properly? If not, redirect them. And if there are no other errors, then give me the successful result. Otherwise, just throw an error. So all I had to do was take my data access layer object and wrap it in one extra function to have all of the exact same functionality. Otherwise, besides that one extra function, these 2 files are exactly the same. Now, if we move on to the admin page, you'll notice it's pretty much the exact same thing again. You can see I'm calling get all to-dos. And this one I'm not actually directly wrapping because I want to show you how this works if, for example, I wanted to do something different than redirecting, because now I have that flexibility. So you can see here, if I have a failure, and my failure is specifically because they don't have access, which means that they're not an admin, I'm just going to put an H1 that says you do not have access to this data. So we can actually go ahead and test this. I'm going to go to my current user. I'm going to change them back to a non-admin user. And if I try to go to the admin page, instead of redirecting me or anything like that, which was the forced behavior from the old example, it now just says you do not have access to this data. So I can really clearly see, okay, what do I have access to? What do I not have access to? And I can do different things. If I was in an API, I could send back an error to the user. If I was inside of this part of my application, I could either throw an error message like this, or I could just redirect the user. I have that flexibility to do whatever I want. Now let's bring us back to an admin user just to show going to that page still does work. And now we get to go back and talk about more things in our application that are different. So here we essentially are just getting our to-dos, and this returns to us that data access layer, which is either an error or all of our different data. You can see down here, we're forcing that successful state to happen, and then finally using our to-dos just like normal. And that's pretty much exactly the same as what we had in the old admin page. You can see all I have is those extra error checks inside of my application. Now let's close out of some of these and look at actions to be able to tell the difference between these, because this is where quite a bit more difference is happening as well. You can see for the most part, our code is the same. We have our insert to do section here, and we have our update to do section here, but there's a few other helper functions I essentially have in place. If you remember, inside the old version, I had to, inside my insert to do function, make sure that my user is there and do all my authentication and automatically redirect the user. But like I said, if I'm inserting from an API, I may not want to automatically redirect my user. So instead of forcing my user to automatically be redirected, I instead have that ability to make them redirect if I want. This insert to do function doesn't do any redirecting at all. All it does is return to me either error or success, and then I can handle that however I want. So in my application, I have a few helper functions that make those default behaviors really easy. So in this case, this DAO login redirect is that one we've already looked at. I just redirect the user if they're not currently logged in. So that's all that I'm doing in this application is I'm inserting the to-do, and if the user is not logged in, I'm redirecting them. Then if it was successful, I just don't return anything because I don't really care. Otherwise, I want to return an error message to the user so they know something went wrong. So I have a really nice little helper function that just loops through our different types, whether it's no user, no access, drizzle error, or unknown error, and it just gives me a handy error message I can show the user, so if they try to do something that they don't have access to, it'll give them an error message. To show an example of that, I can go to the admin page and try to toggle a to-do for someone I don't have permission to, and you can see it says you do not have permission to do this action. So it's very flexible. I can do all these different things that I want to. Now going back, you can see our toggle to do action is essentially the same. I redirect the user if they're not logged in, and then I format my error message so I can show it inside of the UI. So now let's actually take a look at what the actual application looks like for how we handle these different queries. Inside of our query advanced section, you can see here, we still have our database access code just like we did before, but you'll notice there's no information about user stuff or anything like that. It's literally just my database access code. While in my old query, you notice I had all of my different user related stuff and then my database access code. And down here again, I had all my user related stuff and then database access code. Here, it's literally just database access code and then a few little helper functions that are doing all the rest for me. I can still do my caching just like before if I want to, but these helper functions essentially allow me to create these data access layer errors whenever I have a problem. So this first one is called data access layer require auth. And all this function does is it takes in the thing that I want to do, so whatever my database operation is, and it's going to take in any allowed roles. So if this thing is restricted to like admin only or moderator only, you can pass those in specifically, and then it does all that for me. First, do I have a user? If I don't, return that there is no user as a type of error. Next, if the role is not allowed, for example, if I say it's admin only and this user is not an admin, return that they don't have access. Otherwise, perform whatever the function I pass in is and pass along the user portion inside of it. So you can see inside of here, the function I'm passing into here takes in a user and then just calls another helper function called dal_db operation. Really, all this does is wrap my database operation to give me a few little helper things inside of it. And if I look at this, all this does is make sure that if there's an error, it properly handles that error. So it runs my code, and if there is no errors, it just returns that there was a success and returns my data just like before. Otherwise, it catches a few different errors. For example, if I throw my own custom error, that's a database access layer, I will handle that, and I'll show you where I use that specifically. Otherwise, if there's a drizzle error, I handle that. And finally, if there's any type of unknown error, I just make sure that I handle that as well. So this is a really great way to be super robust. It's much more robust than the old system because I'm handling these extra error states that I was not handling before. Now, if we go back into our query section, you can see both of these essentially do the exact same thing. The only difference is this one only allows admins, so I have this little bit of helper code on here. And when you look at this code, it may be a little bit harder at first to understand what's going on because you have these helper functions that are kind of doing things behind the scenes. But for the most part, when you're writing out a bunch of different CRUD applications, most of your application is going to be these CRUD-based things where you have these functions for creating, deleting, updating, and so on. And it gets very tedious to write these out because you constantly have to do user checks, and then you have to do redirects, and you have to do these other things. All that stuff stacks on top of each other. So having these really small helper functions that just say, hey, first check to see the user's there, then check to see if the database operation worked properly, that's going to mean that you can make these simple functions much easier to write because all you really have to do is wrap them in the helper functions you need and then return whatever data you actually want from them. Now, I did mention I would show you the operation where I would have a throwable DAL error. So if we go into the mutation section, specifically in the update to do, you do remember inside this section, originally I was actually returning just a string that was an error. You can see down here, I'm just returning a string that tells them what that error is. But sometimes I may want to return a string. Sometimes inside of an API, I may want to give a different error. And sometimes I don't even want to return a string. Instead, I just want to like show something on the screen telling them that they don't have permission to do that particular operation. So in that particular case, I'm just throwing an error that says they don't have access. That way, I now am able to check for that error inside my data access layer object that I've been using for everything else, and I can just handle it however I want, whether it's showing a particular error message, showing them that they can't do that, just completely redirecting the user. I can handle that however I want, and it's entirely up to me. But otherwise, all the exact code inside here is the same. Wrap it inside of an auth check because this requires authentication, wrap it inside that database operation to check for any drizzle-related errors, and then finally run my actual code. Same exact thing up here, require they're authenticated, require that there's a database action that's wrapped inside of this, and then run my code just like normal. Now I know looking at this code may be quite confusing, which is why I will link it in the description below in a GitHub so you can really dive in deep on exactly what's going on inside here. But honestly, the most important files in this entire section are going to be these helpers and this types section. That's how you can really understand what's going on. Types essentially is just that DAL return, which has that successful state or that error state. So essentially any time that I do any database access layer operation, anytime I go through that data access layer, I'm always going to get returned this particular set of data. It's It's either going to be a success with whatever that database operation is supposed to be, or it's going to be an error, and that error will tell me what's wrong inside that operation, whether there's no user, whether the user doesn't have access, or whether there's some other type of error in my application, and you can add as many different types of errors inside of here as you want. Essentially, success means everything worked as expected, and error means that something went unexpectedly, and now I can handle that in my application by either redirecting the user, showing them an error message, or really doing whatever I want. Now, these helper functions inside this helper function section are essentially just the common things that I'm going to do in my application. For example, it's very common for me to want to redirect the user if they're not logged in. So I created a simple helper function that checks for the user not being logged in and redirects them. That way I don't have to write these, 2-3 lines of code inside of every one of my components. Same thing here. If they're not authorized, I will oftentimes redirect them, probably more often than not. So having a helper function for that is nice. Same thing with this verify success. It just handles the essentially most often use case where I redirect the user if they're not authorized or logged in. Otherwise, I just render out my data as is. That's 90% of the time what I'm going to be doing. So having just a boilerplate use case for that is really nice. And then these ones down here just help when I write my data access layer code to automatically create those errors for me, so I don't have to manually do these checks every single time that I want to do this information. Now, these create error return and create success return functions are super simple. It just gives me type information. Essentially, it's forcing the type of this to be a data access layer return object, and it's either an error or a success. Now, once you master a data access layer, you're going to need to master permissions. So I highly recommend checking out these 2 videos where I go in depth into how to senior developers handle authentication and authorization. With that said, thank you very much for watching and have a good day.